Now, I want to remind you of how inequalities work. If I know that 3 is smaller than 9, if I add 3 to both sides, a positive 3, this would give me 6 and 12. The inequality remains the same. If I know that 3 is smaller than 9, but what if I subtract 3 from both sides? I'm going to get a 0, I'm going to get a 6. The inequality remains the same. If I know that 3 is smaller than 9, suppose that I multiply both sides by 3. Well, I get a 9 and I get a 27, and notice the inequality remains the same. However, if I know that 3 is smaller than 9, suppose I multiplied both sides by negative 3. I get a negative 9, I get a negative 27, but notice the direction of the inequality changed because I multiplied by a negative number. The same thing is true if 3 is smaller than 9. If I divide both sides by a negative number, I'll get a negative 1, and I'll get a negative 3. Negative 3 is bigger than negative 1. It reverses the direction of the inequality. So we can say if you multiply or divide by a negative number, the direction of the inequality changes. The direction of the inequality changes. If you multiply or divide by a negative number, the direction of the inequality changes. Changes the order of things on the number line. So in this case, 2x minus 4 is smaller than 10. Add 4 to both sides. You solve it just like you would an equality, except for that one little thing. And now I'm going to divide both sides by a positive 2. Does a positive 2 change the direction of the inequality? No. Remove parentheses. Plus 2 gives me a 2x. Plus 2 gives me a minus 6. Is less than or equal to 3x plus 4. Combine like terms, I get a minus 2x minus 6 is less than or equal to 3x plus 4. I'm going to put everything on the left, so minus 3x minus 3x gives me a minus 5x minus 6 is less than or equal to 4. Add 6. Oh, isn't that cute? Minus 5x is less than or equal to plus 10. Divide both sides by minus 5. What happens? It's going to flip the inequality, right?
Adorable.
Because I divided by a negative. Adding and subtracting doesn't hurt anything. Dividing and multiplying can. Oh, here's one of these stupid things that's got a fraction. I'm going to put that guy over 1. So I want to multiply both sides by a positive number, namely a positive 12. So I'm going to have 12 times 4x minus 3 over 6 plus 12 times 2 over 1 greater than or equal to, here the 12s reduce out, 2x minus 1. Six divides 12 twice, so this is 2 times 4x minus 3 plus 12 times 2 is greater than or equal to 2x minus 1. Notice I work slowly and carefully. Clear parentheses, 8x minus 6 plus 24 is greater than or equal to 2x minus 1. Notice I keep the symbol, so if I start out with a greater than or equal to, I keep that going until something tells me it needs to change. I don't change it to an equal sign. Combine my terms, 8x, and then 24 minus 6, 18. I'm going to move my x's to the left, so minus 2x, so that 6x plus 18 is greater than or equal to negative 1. Minus 18, look at this, 6x is greater than or equal to negative 19. Only now in intermediate algebra you're going to come up with crappy numbers.
Didn't we simplify the 12 to a 2, so would it be 4 instead of 18?
12 to a 2.
So would it be 2 times
12
2,
to a
12?
2.
So 12 times 2?
No, because he had a denominator of 1.
Okay.
And so that x is greater than or equal to negative 19 over 6. Look.